Okay, this is the Professor, CBMD PhD, and today's Monday, October 23rd, 2023. It is 7:15 and 5 seconds, AM Eastern Standard Time, and today's research, Graphene Nanodevices. So let's jump to it here. Researchers demonstrate a high-speed electrical readout method for graphene nanodevices. Date October 20th, 2023. Source: Toku University. Graphene is often referred to as a quantum material for its advantages qualities with its application in quantum computers, while promising a stymied by the challenge of getting accurate measurements of quantum bit states with existing techniques. Now, researchers have developed design guidelines that enable radio frequency reflectometry to achieve high-speed electrical readouts of graphene nanodevices. As complicating their application in quantum computing comes in the form of gaining accurate measurements of the quantum bit states, most research has primarily used low-frequency electronics to overcome this. However, for applications that demand faster electronic measurements and insights into the rapid dynamics of electronic states, the need for quicker and more sensitive measurement tools has become evident. Radio frequency reflectometry works by sending radio frequency signals in a transmission line and then measuring the reflected signals to obtain information about samples. In devices employing bilayer graphene, the presence of significant stray capacitance in the measurement circuit leads to radio frequency linkage and less than optimal resonator properties, whilst various techniques have been explored to mitigate this. Clear device design guidelines are still awaiting. And to circumvent this common shortfall of radio frequency reflectometry and bilayer graphene, they employed a microscale graphite mountgate and undoped silicon substrate. They successfully realized good radio frequency matching conditions, calculated the readout accuracy numerically, and compared these measurements with direct current measurements to confirm its consistency. And this allowed them to observe Coulomb diamonds through radio frequency reflectometry, a phenomenon indicating the formation of quantum dots in the condition channel driven by potential fluctuations caused by bubbles. The team's proposed improvements to radio frequency reflectometry provide important contributions to the development of next-generation devices such as quantum computers and the exploration of physical properties using two-dimensional materials such as graphene. And this is the Professor of Space Technology, Advanced Physics, Mathematics, Computer Science, and Teacher of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.